Okay, hello. Thanks to be here. I'm Rob. I'm working with cloud technologies, with distributed system, with data for many years. In the last couple of years, okay, I've been passionate about this kind of stuff. So, not the sustainability that's a thing that's an approach that I pushed for my entire life probably, but for green software. I've been involved into the Green Software Foundation, that it's like not a branch but a part of the Linux Foundation, and I speak about these topics because I really want to let you, the audience, the community, be more aware of these topics. Today, we are gonna introduce the main points. Okay, as expected, my clicker ran out. The main points of Green Software Foundation. But before, I just want to give you a couple of clarifications. Okay, in this session, we are gonna talk about carbon and CO2. Okay, carbon is the element, we all know it, and CO2 is the gas that we emit with human activities. Okay, so I apologize because I will use them interchangeably. So just to make a clarification. Another assumption is that we are starting from a world that is fueled by fossil fuels. Okay, that kind. Well, I have also a laser. Yeah, which is oil, coal, and gas. Okay, to a greener one when the sources of energies are solar, wind, and water. And why that's the nuclear here? Okay, because nuclear is considered clean. Okay, so it's not a matter of danger; it's a matter of clean or not clean energy. So that's why it's on the right side. And another thing that is not really connected to this presentation, but I want to give to you as an assumption to let you deep dive in a second time, okay, is what is happening in the oceans when the CO2 is increasing. When CO2 is increasing in the atmosphere, the oceans try to get a part of it, and the pH, okay, the acidity, increases. Okay, so with the acidification of oceans, under the hood, something stopped to live or live in a different way. Many researchers told us that fish and sea life is decreasing where the pH is going down. Okay, when the acidity of the water is increasing. Okay. Another assumption I want to let you just before starting is the overshoot day. How many of you knows what is the overshoot day? Okay, a few. Okay, that's good. Okay, think about our world. Okay, the Earth like a system that produces resources. Okay, so in a year it produces 100% of the resources. The overshoot day is the day from January to December, okay, when we have finished the resources that the Earth can produce in a single year. So ideally, this overshoot day should stay on 31 of December, or even don't get it. But year by year, we are decreasing the date of this overshoot day that have been passed just few weeks or a month ago, something like that. So what does it mean? It means that we are consuming resources faster than the planet can produce them. Okay, and this is not good. Okay, there should be many of this kind of examples, this kind of approaches to read the problem. Okay, but it's not the topic of this session. I just wanted to give you a sort of impressive approach just to now go to the topic of the session. Okay, what's the topic of the session? Green Software Foundation started like 2 years ago, but after the Conference of Parties of November 22, so just 1 year ago, it started to act more faster. Okay, and one of the main goal of the foundation is to make evangelism through the planet onto these topics. Okay, so efficiency, so how we use energy and how to use it better, and awareness, so carbon awareness, so how to produce energy in a better way. Okay, energy efficiency is related to make the most with a given amount of energy. Let's start from this slide. Okay, when we plug the laptop into the wall, do you ask yourself where the energy comes from? I know. You never asked it? Okay, I don't. Okay, I didn't. Okay, that's why, because it seems clean. Okay, so the wall is clean. Okay, no oil. Okay, no gas, no carbon. Okay, in the wall. So I just plug it even here. Okay, it seems really clean, but the energy that is produced here comes from mostly from oil, coal, and gas. Okay, so and how we produce energy by burning that kind of materials. Okay, so burning them is producing CO2. Okay, that is not the only danger in this period of the time. Okay, because if you heard about methane, another gas that is going out some from the soil, okay, that's really that's even more dangerous compared to CO2 for the effect, okay, of in our atmosphere. But this is the main gas we produce with our daily activities, with human activities. Given that, we as humanity should achieve efficiency, and in the software ecosystems we use cloud, or we use data centers, private, public. Okay, the same. What we should achieve is this. Okay, is this index that stands for power usage effectiveness. So it's like a ratio between what is injected into the system and what is actually used. Okay, used by the workloads. So in this slide, we can see that for 15 kilowatt that is been produced by the grid and put into the data center, just 10 go to the server, and the other 5 is overhead. Cooling, lights, electricity for doors, something else. Okay, so it means that the PU is 1.5. It's not a great result. Okay, many of the cloud or the most famous cloud providers, so Google, Amazon, and Azure, and Microsoft, are achieving a PU of about 1.1 or even 1.05. Okay, that's a good result, great result. And it should be convenient, and it is, because if you decrease that index, you are probably consuming less energy. And if you are a cloud provider, if you have a provider, okay, you want to achieve more with the same exact energy. And that's why the mission statement of this session is green must be convenient. So I strongly think and believe that you cannot change the planet, change the approach by yourself, just because of your good actions. Okay, but there should be something bigger, like the convenience of your action, that should lead this kind of transition. And that's why, if we achieve efficiency, of course, we're even spending less. So it's convenient. So even for cloud providers, even for everybody. Okay, so there are many ways to achieve a better PU. There are many research projects to install data centers under the sea, which has any other counter effects, of course, but they reduces the lighting. They created like a contained environment for the data center without human access. They evolved the technology in the latest 15 years. So we are arriving to one. It's impossible, okay, but 1.005 should be a really, really great result, probably the maximum result that we can achieve. Okay, I left just a few seconds to try to understand the slide. Here we have CPU and consumption. What does it mean? It means that when we are like idle with no activity, we are still consuming half of the energy. While when we pass the 50% of the CPU usage, we are consuming pretty much 100% of the power. Okay, what does it mean? It means that we need to maximize the usage of our resources, because it's not linear. So it's better to have a device and use it at maximum. And this is really impactful even for servers. Okay, for your laptop it's not easy. Yeah, of course, in the spare time you can mine bitcoins, but it's not that kind of approach that I would like to suggest. Okay, it's something more related to servers. So if you have a server, it's better to consume all the CPU resources instead to have them like idle or 10%, 20%, because at 10, 20% we are like here. So with a high usage as well. So, and not everybody knows it. So that's why we should think about it. And when it comes to hardware efficiency, so energy efficiency is how to use better the energy that we are putting into the technology. Hardware efficiency is more like to reason to think about the hardware, the stuff that we have and we buy, okay, and to extend the lifetime of those devices. I leave you read this slide for 30 seconds. The first time I watched on this, I was impressed by the fact that production of a device can emit CO2 in a proportion that would never be compared to the usage. Okay, that kind of emission is also called embodied carbon. So like this phone comes out with an embodied carbon of 8 kilograms of CO2. Okay, please read the numbers as indicative. Okay, but just to give you a proxy. Okay, so what does it mean? That by producing that smartphone, the factory emitted like 8 kilograms of CO2. So it's better to extend the usage of this device. And that's not the only information of this slide. Another interesting information is like for a smartphone, the usage part is not neither visible, okay? While in a TV, we are telling that probably in a year, we are consuming just a slice. We are emitting just a slice of the CO2 that is emitted for the production on the entire television. So be aware of those kind of promotion, incentives. In Italy, we had an incentive that was really crazy to recycle your TV, okay? Recycle your TV of just like 5-6 years old. And it's completely against the sustainability direction, okay? It's something that makes no sense because of that, okay? So even before you touch, okay, your new device, it emitted a lot of CO2. So the next point, of course, is to extend the lifetime of the device. And since we are talking about software, since we're talking about cloud computing and data centers, okay, our main focus should go through the servers. Okay, so if the production of a server takes around, it's a proxy, this 4,000 kilograms of CO2, in 4 years, we can imagine, like in an amortization plan, okay, to consume 1,000 kilograms for a year. It's not true, okay, because all the resources have been consumed at the beginning, okay, but we can imagine this kind of amortization. So the easiest thing to do is to extend the lifetime of the device. So it's easy, so no rocket science. It's just please use the hardware as much as you can. And I say 5 in this slide, but it can be even 6. There are special service providers, cloud providers, that are specialized, they are even low cost, they are specialized in keeping all the old hardware from major cloud providers and put them in second-hand racks in a way that they are not so available or reliable. Okay, we know it, but we can design application to be fault consistent. Okay, and they are in the right direction. So extend the lifetime of server of 10 years, and this could be a game changer. Okay, so simple. Yeah, it's not rocket science. And this is another point of view. Okay, we've been told in the last 10 years, for 15 years, since the cloud, okay, that it's better to scale out than scale up, and it stays. Okay, so it's true. I am a big fan of this, at the condition that when we scale out, we should maximize our resources. It's better to have one server at 100% than 5 servers at 20. Okay, we cannot do this always. Why? Because if we go in the public cloud, they have complete interest to make the things working like this. So pool many clients, many resources on the same server to achieve 100% usage. That's why if you use platform as a service, serverless, and other technology like this, you don't buy infrastructure, you don't buy VMs. You just buy like a proxy, a number, like 100 compute unit, okay? And you don't even know if that compute unit is just a slice of a bigger server. It is, 99% it is, okay? And that's why it's convenient for the cloud provider, because they can pool resources into single servers, okay, and achieve more utilization, okay? And again, they do this because it's convenient. So they don't do this because it's because of an ideal, okay, but because it's cost effective. In private cloud, I'm not saying it's not possible, but it's harder. Why? Because if you cannot use a platform or serverless technology, you should probably oversize your pool of servers, your infrastructure to manage the peaks. So I'm not telling that is a mistake, but it's very likely that in a private cloud or in a private data center, you cannot really achieve this kind of utilization, except if you have a nice level of automation technology that recreates those conditions. But even on those conditions, even cloud providers, they have spare capacity to power up in case of peaks. So it's not easy, okay? But what I want to tell with this slide is that cloud providers are really encouraged to go in that direction more than us from a point of view. Good. And the last part were 3 pillars in this session. energy efficiency, hardware efficiency, and carbon awareness. Carbon awareness is about your awareness, our awareness, not to how to use energy better, but how the energy has been produced. Okay, and let's take a look at this slide. Oops, sorry, clicked the wrong button. Okay, and okay, this is time, and at T1 we have this mix that can be called a mix, okay, because we have a slice of solar, slice of wind, and then gas and coil. But after that, the mix can change with the same exactly demand, okay. Why? Because of this. So no wind anymore, no sun anymore. So there's water, okay, but let's keep it simple, okay. And in that case, we need to increase the burning process of coal and gas. Okay, so which is the equation here? The equation is, I suggest the approach, let's try to use the most of our resources when we have this coverage. Okay, but we will see it later. Okay, this was just to give you the point that for the same demand we can be greener or not. So we can, for the same demand, emit an amount of CO2 or another one at the same input conditions. Another concept that is related to carbon awareness is the curtailment. So it's quite hard how the energy is to get all the connect the dots about the energy production. Okay, but I think that I learned is that a factory that produces energy can never stop. Okay, you can just say, okay, turn off the factory because there's the wind, there's the sun. Okay, it can be possible. So if you have a lot of sun, a lot of wind that is producing energy, you need to keep the plant on with like a minimal level service. That minimum can be this part. Okay, so which is the point of this slide, that if we have this demand, okay, and we burn a lot of fossil fuels, after that wind and solar increases their capacity, but I still need to burn a minimum of fossil fuels. So the excess is like wasted. And that's a pity. Okay, so that's why researchers are trying in the last years to find creative ways to avoid this kind of loss, maybe with international grids, connected grids, not accumulators. Accumulators are good in theory, but not so good in practice. Okay, because we cannot scale out with batteries. Okay, so much. So probably the turning point will be to interconnect grids from many locations to use the energy of Lithuania from another country because of the connection, because here there's the sun and in the other place it's raining, okay, with no wind. This could be the turning point, the reading perspective. Well, let's talk about what we can do, okay, in software, in our development process, and in our company. Okay, there's a concept that's called shifting. Okay, that says, okay, if I know that in Spain, okay, they have a average mix that is greener because they went in that direction in the previous 20 years. Okay, so I don't know the numbers exactly, but let's say to 80% of the energy is green in Spain, while here in Canada no. Okay, the question is, may I run the workload that was initially scheduled here? If yes, we can do this. Of course, let me give you an example. We are in a big data conference. I have data lakes. Okay, so if I imagine to send between Canada and Spain every day terabytes of data just to execute the workload when it's greener, probably it's not convenient for the egress, for the bandwidth, and the bandwidth itself is consuming energy and emitting CO2. Okay, so you should think about the balance, and you should think about projects that can be sustainable. Let me make you an example. If you have a machine learning model, okay, that adds a huge data set, not so huge maybe, okay, but a computation period of hours, days, okay, that can be pushed to another location, let it run over there, and then the result can come back to the original data source. From the cost perspective, you should be pushed to do this, because if it costs the same, you will probably say, okay, I don't make this mess just because it's greener, okay? But it is, because if you read the prices of the different data centers in a major cloud provider, you will notice differences. And differences, there are differences because of the cost of the energy, because of geopolitical reason, but energy is one of the piece of the equation. So this can be effective for some workloads. Another approach, it's always shifting, but it's not space shifting. Now it's time shifting. So from the beginning of my career, I was accustomed to read the cron jobs running during the night. Okay, so legacy ETL that runs at about 10 p.m. for hours, okay, because the next day we should have fresh data. Okay, now it's not true anymore. We have streaming, so data is not really static and fixed as we had like 10 years ago. But if you have something that is running over the night, try to reason. The night is the best time for the energy, the carbon footprint that it can make. Probably not, because in the night the sun does not shine, and the wind, it doesn't matter at all, okay? But you should probably execute your code when you know exactly that in that time you should pick the energy from renewable sources. How to do that? It's not easy, and it's not so easy to implement, because if you need to run during the night, you should run during the night, okay? But if you can decide, you can run in a specific time frame when there are a couple of SDKs, APIs, okay, that should call to ask, okay, in my zip code, which is the mix right now? So if the mix is more equal or more than like 80% of renewable, so start the job. There are also projects for Kubernetes and KEDA. KEDA is like the Kubernetes event-driven scheduler that autoscaler, sorry. That's a project that lets you bind the execution of a pod if there are certain conditions. Okay, you can create an item on Kubernetes that is activated only if there are some energy conditions. Okay, it seems intriguing, probably challenging. Yes, it is. We implemented it. No, not a big deal. Okay, so we are not reducing by half the emissions. Okay, but since it's not so hard for us to schedule in different times our workloads, it was quite easy. Okay, the last thing, okay, is a couple of approach to measure your impact. Okay, when we are talking about reducing emissions, my personal opinion, that's backed by researchers, of course, but it's like an opinion because I know many companies that has different approaches, is that the best way is to not emit. Okay, so not emit anymore. Emit the less you can. So try not to say, okay, I'm emitting so much, but I'm planting trees. No, it's better to not emit. Then we can also planting trees, okay? But not emitting could be the solution. Why? Because in the other side, we have offsets. Offsets is a way that we decide as humanity to handle the problem until a couple of years ago. So we thought that we can even consume and produce CO2 if someone else in another place of the planet may help compensating by planting trees, by capturing CO2 from the atmosphere and so on. Yeah, it can be, it makes sense in a way, but I also saw spots on the TV like you don't need anymore to have issues about your consumption because you can even compensate with us, like the company that compensates with the CO2. It's a wrong message, okay? We cannot rely on compensation. We should rely on abatement. So elimination, okay? Try to do not emit anymore. After that, since probably we cannot eliminate all the CO2 emission, because even if we have 19% of renewable energy, if we extend the lifetime of our devices, if we achieve 100% CPU in usage for all our servers, probably there's a small part that is not avoidable, and that can be compensated. Okay. So this approach is called net zero. So try to achieve the zero emissions. This is the last part, not the one before. Measurement. We arrive from a decade of measurement based on absolute numbers. So let's give me an example. We are a company, not mine, fictitious company of 100 people, okay? And we set the target of footprint to 100 kilograms per year of CO2. It's very, very a few kilograms, just the matter of to simplify the calculations. Is it really interesting talking about the consumption, the footprint in terms of absolute kilograms of CO2? No. Why? Imagine you say to investors, okay, in the next year, we want to achieve, instead of 100 kilograms, 80 kilograms of CO2. But during the year, business is going really good, so you double the person that work in your company and probably even the revenues, and your CO2 goes to, I would say, 150. It's bad? No, it's a great work, because you double your activity, the person, the revenue, and you didn't double your consumption, but you set the target to 80 kilograms. So absolute measurement, it's useless because it doesn't take into the equation the unit of your evaluation. So it's better to say, okay, if we have still like a revenue of 1 million and we are 100 person, I would achieve 80 kilograms. Otherwise, like in a proportion, I would achieve that kind of consumption. This could be better, okay? And that's why Green Software Foundation introduces the concept of SCI. This new, it's quite simple, okay, way to measure introduces the concept of fractional unit. So measure your carbon footprint is very hard. If someone of you tried, you will probably know it. But if you have an application, okay, let's try to simplify. We have an application that is like the e-commerce, a database or something like that, and you should measure all the points around this application. Okay, not easy, but you can. This can be your fractional unit, the e-commerce application. And if you measure the energy consumed and the portion of this energy that emits carbon, so the non-renewable one, you have the piece of CO2 produced by the energy. After that, you add the embodied carbon. So do you remember what is the embodied carbon? Is the carbon inside, okay, a device because of its production. Good. And you put this calculation for a given unit. So you can say my e-commerce application consisting in a web app, database, a CDN, okay, and the storage is consuming 100 kilograms CO2 per year. So my target is to achieve 80 for that fractional unit. Okay, and you can say, yeah, but if my e-commerce has like 10 customers, it's different if it has like 100 customer or 1000 customer. Yeah, of course you can change this fractional unit at the beginning. So if you do your homework correctly, the fractional unit is not the e-commerce application, can be the e-commerce application with 10 users. So you can recalculate it year by year and have a good measure and a better approach than the one we used before. So I thank you. I tried to give you some spots about Green Software Foundation. We talk about energy efficiency, so how we use energy better. We talk about hardware efficiency, so how to achieve more from existing devices to extend their lifetime and consume less in perspective. And we talk about carbon awareness, so how to understand the main pillars of production of energy to say, okay, that's something that can do to reduce our impact, so running workloads in a specific region or in a specific time frame, or even eliminating some kind of workloads. And that's all. I really suggest you to go to the Green Software Foundation initiative. If you're interested, you can contribute to the project. I translated the website, the learning website in Italian. Another German translation is ongoing as well. They have like a champions, like a speaker panel for people like me that is telling you this kind of stuff. We have the Carbon Aware SDK, so a collection of projects that are in that direction. My colleague in Italy developed a plugin for Kubernetes to automate more how to achieve scheduling based on the energy conditions. And there's also the paper, the white paper for the SCI specification that is very simplified, the thing that I already just showed in the measurement part. I thank you, and I'm here for a question, if any.